I feel a little like Daniel in the lion's den at the moment after all of that high tech. Yeah? So I will say by defense, back in the 90s I was doing some of the early work on how you use genetic algorithms to select between neural networks. I can't endorse that one speaker, we're neglecting neural networks in the favor of large language models. I currently work on anticipatory awareness, so how do you trigger executives to alerts on things they would not otherwise see? So the role of AI, the role of technology is critically important, but we're underestimating the role of humans, and we're trying to use technology models to understand human process, and it doesn't work that way. Yeah? I'll go through this in some detail in a second, but I'm going to argue in a minute, and I will actually use French philosophy. My background is physics and philosophy as a joint major. You'll see that come through. So you're going to get Deleuzian epistemology as assemblage theory later on. And I am going to talk about bricolage, which is a really important concept in this, so I can reference back to the start with those two. Right? The field we work in is called Sensemaking. It's used with a hyphen. Sorry, in academic terms, hyphens are very important. With a hyphen, it's a verb. Without a hyphen, it's a noun. And we define sense-making as how do you make sense of the world so that you can take action in it. And you never know everything you would like to know to make a decision. So what sort of decisions can you make based on what you can know, either now or in the immediate future? And that's the kind of key principle. Naturalizing, that comes from philosophy. It means to base what you do in the natural sciences. When I studied physics back in the 70s, we used to say that social scientists suffered from physics envy, which was a deliberate play on words, but I kind of stand by it. They never have enough data to form any valid conclusion whatsoever, and you get extensive confusion of correlation with causation. Right? To give my favorite examples of that, if France wants to increase the number of Nobel Prizes it wins, all it actually has to do is increase dark chocolate consumption. There is no need for education. Dark chocolate consumption per head of population directly correlates with Nobel Prizes for head of population for the last 50 years on a bigger data set than you will see in any social or management science, so go and eat chocolate. The one which I actually think is causal is peaks in attempts to commit suicide by drowning, directly correlate with the release of Nicolas Cage movies, but I can see a reason for that. Now, I make this to make several points. One of the major problems about half our work is in the health sector at the moment. We think we've finally found out how to measure placebo effect, which is going to be really important downstream. But actually, when you look in that section, these days it's all about statistical correlations, not physiology. And that's becoming an increasingly issue in terms of the way we do science in social systems. I'm going to talk about the work we're doing on citizen sensor networks. We've been experimenting with using school children as ethnographers into their own environment at huge scale in order to better understand the reality of human attitudes. So human attitudes are lead indicators, compliance is a lag indicator. I'm giving you a flavor of this, right? So the most significant illustration of the naturalizing, because we start with what's the problem, we then spend 4 or 5 years looking in biology, physics, whatever. I agree biology is undergoing major change, but physics even more, actually. There are 2 bodies of theory in physics, assembly theory and constructor theory, which are now starting to argue that information has momentum, which has major significance, and I'm really quite attracted by those 2 because it makes a lot of sense with other work we're doing. But basically, we say spend 4 or 5 years on that, then we move into experimental stage, and then we go into operations. So we don't start with cases. We start with valid theory, which has been subject to peer review. And one of the reasons we do that is this. I don't know what radiologists have done to offend the cognitive neuroscience community, but they did something really bad at some stage. If you give radiologists a batch of X-rays, you ask them to look for anomalies. On the final X-ray, you put a picture of a gorilla, which is 48 times the size of a cancer nodule. 83% of radiologists will not see it, even though their eyes physically scan it. That one scientific fact invalidates all systems analysis, all consultancy interviews, and everything else. We only see what we expect to see. And one of the reasons, and this is Clark and other people work, we're constantly micro-hallucinating. And by the way, humans hallucinate computers, AI, bullshits. It's completely different. Yeah, AI is trying to persuade you we understand hallucination. So the hallucinations come from our own partial memories, from the memories of other people through their stories, from our physical environment, from pure imagination. And those hallucinations constantly entangle with multiple sensory stimulus. It's not just oral and visual. We know that scent is key on trust determination, which is a problem with virtual space. You're not getting the signals you expect to see. There is stuff about resonance we don't fully understand yet. So we do not yet understand all the sensory data that human beings make to make decisions. It is not confined to text and tokens. And that's really significant if you think about it. So those all entangle constantly. And then we do a first fit pattern match, the first pattern which appears to admit we apply, not a best fit pattern match. We satisfy, we don't optimize. This makes a lot of sense if you think about the early hominoids on the savannas of Africa. Something large and yellow with large sharp teeth runs towards you at high speed. Do you want to autistically scan all available data, look up a catalogue of the flora and fauna of the African veldt, and having identified lion, look at best practice case studies on how to avoid lions? By that time, the only document of any use to you will be the book of Jonah from the Old Testament, which is the only example I've found of an escape manual from the digestive tract of a large carnivore written by a survivor. We evolved to make decisions very, very quickly based on a partial data scan, privilege on our most recent experiences, and using the stories of the societies we grew up in as scaffolding for our consciousness. Modern theories of consciousness do not say that consciousness is a distributive function of the body, the brain, and its social environment. Right? Now, it's really important to understand because our scaffolding into our environment is why we only need those 20 watts, whereas AI requires us to actually damage the planet even more than we were already damaging it, yeah, in terms of energy consumption. Right? So that's actually the way human beings make decisions, and we evolved that way because overall it gives us survival potential. So we want to work with that, not against it. So that sort of physical aspect is key. The other thing is we all tell fairy stories. Does anybody tell stories about how Jonathan John stayed at home, achieved the company KPIs, followed the company mission statement, and did what Mummy and Daddy said? Anybody think any kids would listen to that? All fairy stories are stories of failure. And the reason is avoidance of failure is a more successful evolutionary strategy than imitation of success. We build worse practice databases for companies because they carry more learning than best practice databases. If we run human-based simulation games, after 3 rounds of complete failure, people are scanning 20 times more data before they make a decision than if you actually train them to succeed. Now, I'm trying to give you some basic facts on which we're going to build. And then the other one is the famous, you've all heard this phrase, why didn't we join up the dots? When anything goes wrong and we look backwards, yeah, congressional report on 9/11, all those sort of things. Well, if there are 4 dots, there are 64 possible patterns that can form from the dots and the linkages. Just have a quick guess in your own mind. If there are 10 dots, how many patterns do you think there are? 4 dots is 64, how many on 10? Most people, I've seen estimates as low as 150, some people go into millions. It's just over 3.4 trillion. If I go to 12 dots, it's just over 4.8 quadrillion. With the benefit of hindsight, anybody can identify a causal pattern, but hindsight doesn't lead to foresight. And that's a real problem when we do lessons learned and everything else. And there's a famous Chinese story about it, the emperor's chessboard, asked for a reward. It was actually an Indian emperor, I think. Somebody explained the game of chess, and the emperor loved it, so he said, what reward do you want? He said, 1 grain of rice on the first square of the chessboard, double thereafter. There wasn't enough rice in China. So one of the key things coming from complexity science is we must realize the importance of the fact that retrospective coherence is a real danger. When you look backwards, you can always see a causal chain, but that causal chain may not be aware to you at the time. Right? And that breaks a lot of things you see in systems thinking, which is not the same thing as complexity science. Complexity is known as entanglement. I'm not going to go into a huge amount of data on this, but the Latin root word of complicated in English means to be folded, and things which can be folded can be unfolded and folded again. The Greek root word of complex is actually entangled, and something which is entangled cannot be unentangled and tangled again. And the thing about entangled systems is they have high levels of path dependency. Whatever has happened in the past cannot be ignored. You have to start with and wreck it. So complexity is known as a science of uncertainty. It gives us a new way of looking at things. And there's kind of like a limited amount on this. That's a termite's nest. The entire termite's nest construction arises from genetically encoded rules responding to 64 pheromone traces. Yet there is no directing intelligence. In a complex system, we can manage basically two things. One is we call actants. That goes back to Latour and actor network theory. An actant can be a human being, an actor. It can be a constraint, a legal restriction. It can be a constructor, and I'm not going to constructor theory at the moment, but that's a really important area of development at the moment. A constructor is a process or a ritual. It's something which changes things, but doesn't itself change in the act of transformation. That's really important in terms of distributed healthcare. It's actually building human constructors. And we can control interactions. So basically, you've got lots of actants, lots of interactions. They're highly rich, they're highly local. None of the actants is aware of the whole. And what you're monitoring for, which is why monitors are important, is emergent patterns to which you can respond. And then we also create scaffolding, we create structures which give us certainty. In France, you drive on the right. In Britain, we drive on the left, and so on. So if you're managing in a complex world, those are kind of like the only four things you really need to pay attention to in terms of things you can change. What you can't do is say, this is where I would like to be, and close the gap. In complexity, we focus on where we are and where we can go next. And there's a lovely quote from Seneca on that, which is and this is the key work we're doing at the moment, is to use mapping of the present as an alternative to scenario planning. This comes from constructor theory and physics. If you know the energy gradients of the present, you've got a more predictive mechanism than trying to forecast the future state. Right? And the way that works is fairly simple. First of all, we look at those actants. Remember, actors, constructors, constraints. We map them onto a very simple grid between the energy cost of change and the time to change. And those all get mapped. We can do this with software, or we can do it with people. If we do it with people, we get them to break things down until there's agreement. That is a very simple instruction, but it has a major effect. I've just come back from working with NATO on Joint Command. The big issue in strategy is consensus on the current situation, not on what our goals would be. And the trouble is, nobody can accurately assess the current situation if they're thinking about what they do next, because they select the evidence to support what they want. So we've worked on how we break that pattern. So basically saying, what is it? Break it down until you agree. Where is its place? Break it down to what you agree. Is a really simple process. We've just done one big one of these with Volkswagen Audi Group to reduce strategic tension in major fights. Yeah? So you start on that basis. We then draw three lines, the counterfactual line. Anything effectively to the northeast of that line isn't going to change. The energy cost is too high, the time is too high. This is really important, by the way, to de-risk projects. Because if you start with a group of high-level executives with some very expensive consultants in an off-site meeting for a day, I can guarantee you're going to come up with idealistic goals which will probably fall in the counterfactual domain. The consultants want that, by the way, because then your project will fail and they can sell you the same process every 2 years, which is the way their business model works. And I'm not being cynical there, that is actually how it works. Yeah? We also identify a liminal area, and this is really important in human sense-making. So these are things that we can't change, but we realize we might be able to. In innovation, identifying these makes a huge difference, because it allows you to focus your effort on, hang on a minute, maybe we could. We also found with one of the big pharma companies, the minute we finished that, we were looking at clinical trials, the CEO came in and said, well, nobody's goddamn asked, because nobody had actually thought to ask, because they'd taken it for granted. And then you have the highly volatile area, the area where we're really worried about what might happen because it can change very quickly. Now that's called an affordance map. It maps what's afforded to you by the current situation. It takes 2.5 days. It's really simple to do. It's a massive de-risking program, and it's a focusing program on what you can change. And of course, once you've done that, there are things that you can't attribute. That's a risk factor. And then you start to shift them around on that map because you want to change the environment so that the things you want are easier to happen. And this concept of managing energy gradients is the big new thing in management science. Yeah? And actually, that's where technology can augment it. The second thing we need to do is to map the assemblage. This is Deleuzian epistemology. It's strange attractors in complexity theory. You all know this way this works. I tell a story, you tell a story. We like each other's stories. So we listen to more stories like those. Now, that didn't used to matter when we lived in villages because there was human buffering. As a friend of mine in the Canadian Secret Service says, it used to be that every village had an idiot, but it didn't mind because we knew who the idiots were. But now the idiots have banded together on the internet to elect a president of the United States. Sorry, I didn't say that, all right, to legitimize idiocy, right? Unbuffered feedback loops are really dangerous, and AI is making that worse, not better. AI is feeding off its own output now, which is degenerative. It's exaggerating differences, and we all know what that means. So increasing human buffering is key. But once those stories get to a certain critical mass, and this is Deleuze's insight, they create what's called an assemblage, and that's a bad English translation from the French. This is also translated as bricolage. You can't escape the attractor well. What you see with Trump in the United States is there's a narrative pattern that people cannot escape. And a lot of our work, and this is work I'm working on in the States next week, is to say, Deleuze says this territorializes the space so nothing can change. You don't deterritorialize by logical argument. You do it by breaking things down and allowing them to recombine in novel ways. Yeah, in Wales, and by the way, I'm Welsh, not English, now you know that that's important, and it's Cynefin, not Llanefin, but Welsh is phonetic, all right, and I won't pronounce French. One of the things that we're focused on, and this is where we're using the school children, is if we get children to gather stories every week. And the thing we did for the US government is to quantify storytelling, not by analyzing the text, but allowing the person who tells the story to interpret their own story into a semiotic framework. That also means it's called epistemic justice. We're giving people the right to interpret their own experience rather than have it interpreted by AI or an expert. But it also means we can gather huge volumes of data at scale, which, by the way, is used to create training data sets, which are epistemically balanced. Now, if I've got children gathering stories every week and I can draw those sort of maps, I can see the pattern of belief or attitudes, and again, you can see the importance of this in healthcare. We know that placebo effect is major in oncology. The ability to measure attitudes becomes really important in understanding human use of systems, and that's one of our focus areas. Attitudes are lead indicators, as I said, and this actually leads to a new mechanism for change. I can literally point onto those maps and say, I want more observations like these and fewer like those, and I can gauge anybody in that, right, in terms of change mechanisms. And by the way, that's where AI comes in terms of training. I won't go through that because I'm running out of time, but I will just make a general comment on this. This is the difference between a Gaussian and a Pareto curve. Yeah? In a Gaussian curve, you've got relationships between the past and future state. In a Pareto curve, there's no relationship between the current state and the past. Right? So if everything is completely separated, you get a Gaussian curve. The minute you get connectivity, you get a Pareto curve. And in the tail of that Pareto curve, there is no valid training data. Computers and AI works off inductive logic. Humans work off what's called abductive logic. We evolved to make decisions in domains without training data. And one of the key factors in that is art comes before language in human evolution. And what art allows you to do is to actually move to a level of abstraction so you see completely novel connections between things but you disconnect from the material. We're now doing that work on innovation because if you take a company's capabilities, you index it in terms of high abstraction metadata, you take customer needs, you index that in terms of high abstraction metadata, you smash the databases together, and you see patterns where your capability matches customer needs, and you ask questions. Remember, in 1947, a Raytheon engineer realized the significance of a chocolate bar melting in his pocket. We got microwave ovens. In one project we did in Netherlands, we ended up deploying a technology designed to handle urine-saturated staircases at Eindhoven Football Stadium to create a new type of garden ornament which is selling like wildfire, but I'm a bit ashamed of it. Yeah, this is called managed serendipity. The ability to use what you already know for something completely different is a key crisis management process. So, coming to the end on this, the final thing is an agency. You all know that in forests, the fungal roots connect the tree roots. The fungal roots can actually redistribute resources to younger trees in a drought. The equivalent in human systems is informal networks. We can now stimulate the formation of informal networks across silos so that within 18 months to 2 years, everybody is within 2 phone calls of everybody else. Because if you build the informal networks, you create far better opportunity for innovation than getting people together to have discussions on a transdisciplinary basis. We're now starting to do that in universities as well. Antelope align. Each antelope, if there's a predator, identifies another antelope and places themselves between that antelope and the predator. That means the herd holds together. One of the things we're now looking at is how do you create alignment within organizations rather than having goals or purposes. Because what matters is we stay together and we can respond very quickly to uncertainty. And then the big one we're working on, this is bee swarming behavior. Bees actually, through multiple interactions, something called a waggle dance, without any directing intelligence, always find the best possible hive. And I'll make this as a point which is really important. In nature, optimizes without any directing intelligence. And that's why it works. Right? But you can't just do biomimicry, you have to think about the human equivalent. So, I asked AI to draw me a 3-legged goat. Now, I think an artist could have done a better job. The reason for the 3-legged goat, and this is my final summary, is this is military black humor. It's called weak signal detection. If you see a goat with 3 legs, it probably means there's a bomb factory nearby. Yeah? But as I say, that's what AI produced. Right? So summary in terms of project management. Yeah? First of all, this questionnaire matching is called the substrate or the affordance. What's the environment in which we're working in? What can we realistically change? Becomes a key first step. Right? Actually running into a project without doing that first is crazy. And I'll tell you from multiple experiences now, you then find better directions of travel than the one you originally planned. Secondly, you need to start to make micro changes to that because you want to reduce the energy cost for the projects you want to succeed. Effectively, you're creating a garden before you decide what plants to grow. Yeah, and that's actually an important metaphor here. Third one, continuous scanning. What we first did this with the US Army in Afghanistan, which is hence the 3-legged goat. And what we did there was basically we said to company commanders, if you keep your patrol reports up to date, you don't have to write a patrol report. That gave us real-time data from human observers to go with machine data. This was done with a big Italian defense firm. We could actually get anticipatory triggers to say there is a chance of a bomb here. We also reduced the stress on officers. We're now doing that in large public transport infrastructure projects. We're replacing all reporting with continuous narrative capture by each agent, which actually means we get better data and we get earlier warning of project failure. I've been a project manager. You never report failure until you've done everything possible to avoid it. With this, we can get that indication early. Then there's kind of like risk factors on this. One of the things we want to do is to start a more experimental stage. I'm not going to go into that because I've run out of time. Distributing the decisions, we're now working on end-of-life decisions in British hospitals by which a combination of surgeons can make a decision without bureaucratic control. Now, if you don't know it, extended families have a maximum of 7 decision makers. We will compromise in groups of 7 or less. We won't compromise in groups larger. By actually creating groups of roles and making one of the roles completely anonymous, we can actually have money distributed and decisions made literally same day, rather than going through review processes. So you see how this sort of stuff applies. We start to rethink it, and that reduces risk. I've talked about mapping knowledge so that you can repurpose stuff. And I've talked also about human-mediated games. Yeah? Now, what I wanted to do here, and this is very high level, by great irony, I'm actually teaching this stuff in Paris in December for the first time ever. But one of the things we're starting to do is say, if you take a science-informed approach on this, you start to understand what human beings do well and where technology can augment it. Right? Basically, I've seen pictures which say AI has made, Boston Consulting Group published this, study by Harvard, Oxford University, AI has made us 40% more productive. That doesn't tell you AI is any good, it tells you about the absolute poverty of management consultancy. Right? Basically, as a general heuristic, if AI can do it better than a human being probably shouldn't have been doing it in the first place, because it's not adding value. And I had a major argument with Sam Polizano when I was in IBM, and he said, we can get rid of middle management with AI. I said, where the hell do you think senior management is going to come from? A huge amount of what we're allowing AI to do, we need to do to develop the capacity that AI hasn't got. And I'll leave you with one thought. American elite schools, which is where all the tech bros send their children, have banned AI and technology from the classroom. Because they know the development of human capability will give their children major advantage. Those being trained on AI are basically fodder for jobs. Thank you very much for your time.
Thanks a lot, David. Now, this is inspiring. Maybe I need to change a little bit of my management practice. We have time for questions, at least one, on this not easy topic. If there's none, I'll start with one. So you've explained us the framework. I bet you are encountering and meeting a lot of people, government and stuff. For companies, what would you say is the #1 single behavior that you detect where you see, well, this has to maybe shift to another approach?
Okay, I'll be slightly wicked here. There's an asset you can have if you want. My centre wrote the European Union Guide to how to manage complexity in a crisis. There's a joint publication of the Cynefin Centre and the Future Systems Unit of the EU. Being as you're still in the EU, you can get copies for free without paying postage. In Britain, we have to pay postage, all right? So it's in there. What it fundamentally says is you need to manage an organization to handle the unknowable unknowns, right? Which is a very different approach. And so the key thing is not to think about behavior.
Okay.
The key thing is to think about processes which will generate the behavior. And I'll give you a really simple example. When I first went to a Welsh grammar school at the age of 11, we were allowed to wear long trousers for the first time then as well, which in a British winter was a blessing. But I remember I had to walk up to the front of the class and I got given a card and it said, "You support capital punishment." Yeah, my mother was leading the Welsh Labour Party campaign against it at the time, so the teacher was being mischievous. But I had to speak for 7 minutes without preparation for something I profoundly disagreed with. We did that every week from 11 to 18. That made us generalists. It made us understand arguments. It actually made us better human beings, I think. But it was a process which generated the behavior. Nobody tried to change the behavior.